Hello. We come to the what you call important thing, saying why not have something which is practically made by a machine and it is fast, because all of the other things what I have shown you invariably have tremendous involvement from the what you call a trained person, as a self trained, or he is actually he has a diploma in that. The people we work with, all of them are have a engineering or artist degree with them, and hence life is easy for us. But outside, if you are a small timer, it is expensive to hire people. So we come to, if you look at my display, we come to the whole concept of a rapid prototyping. Since the introduction of stereolithography in 80s, RP has come of age. Representative parts and tools can be produced almost instantly directly from CAD data. Speed, accuracy, ability to produce components with complex geometry which would otherwise require expensive tooling. This has provided new opportunities for designers to test ideas and concepts increasingly quickly. So, this is old. Right now, only this and what is now being covered everywhere else will come. Stereolithography once upon a time was common. The original and most popular rapid prototyping, the model is built up in layers in a bath of photocurable epoxy resin, which is solidified by laser, produces accurate, strong and translucent parts. Why I continue to stress on this is, surprisingly, the file formats which are made for this have become standard. All 3D printed parts use STL file extension, which is nothing but stereolithography. One of the earlier things, it is modified mildly now, and you have a little more control on it. So, all 3D printing even today is done with STL files. We have so many, we have DXF, then we have IGS, we have so many other things now. None of them can directly be used by printers, but if you give a STL file, all printers accept it. However, if you have other files also, there is no issue about it. Any of the 3D solid modeling files, or even some of the surface modelers, can easily be converted to STL, sometimes via basic DXF. Or DXF is an old thing started probably by Autodesk. Previous to that, we have IGS extensions. The moment you use those things, you can print. So, stereolithography was probably one of the earliest points. Next, we came to 3D plotting. You see, utilizes a print head to either fuse a powder or deposit molten material in layers to build up a component section by section. As similar to inkjet printing, with the ability to build the vertical direction, especially suitable for small intricate parts. Long ago, we had both the ABS molten plastic being deposited or a powder. Right now, almost all of them have been converted into using fused filament depositing modeling, FFDM. So, you have a FDM is fused deposit, filament depositing. They have a thin wire like thing which is fed, it is heated, locally it is melted. Like let us say, just for this thing I am telling you, the original wire may be as thick as this. Of course, a little thinner, but I am just, it will not catch it, and eventually it will be made into 0.2 mm or 0.3 mm small thing coming out of a nozzle using a heater. And all methods are there. One of them, this is stationary, the table moves, and one of them table is stationary, this moves and all that. So, fused filament deposit modeling has become the de facto standard. The other thing, including stereolithography, including other methods are there, little expensive, not easily amenable to tabletop and so on. Finally, layers of ceramic paper or plastic sheet are bonded together, with each layer being cut to the required section profile with a laser. Completed models have a wood-like feel and can be used either tooling or concept models. This also is very, very interesting. Probably it started with architects who are only using variants of cardboard, understand, no, simple cardboard, and other materials have come about, including foam board, including foam core board, that is both sides you have paper and you have a foam inside. When they wanted to do this undulations on the ground, saying you have a vast acreage of place and then it has a gentle thing. First thing they had to do was somehow recreate the effect. So, you must have seen maps and which have iso lines. So, what could they be? They are points of same height were all plotted together. That is how first surveying started about. You understand, no? If you see a map, we have these iso lines, all of them representing the same height being plotted on that. So, immediately you know it was a very easy way. All somebody had to do is take the map, trace it onto a piece of paper, cut it, place it on a cardboard, and then we had this beautiful way of creating the built environment outside. There is a beautiful name for it. Suddenly, you know, my mind has gone this thing. One variant is called landscaping. So, how to make a land like a beautiful this thing. Interior designing, similarly you have a garden designing, everything, all of them started with using flat cardboard in which contours, land contours which are already available on via survey. So, that has been extended somewhere. If you take a contour, take a thick cardboard and most contours are plotted with 10 feet height, then you also have 1 foot height and then you have other things, no. So, if you have a 10 foot height contour and then if you are making it a scale model, usually 1 foot is made into 1/4 inch. You make a cardboard of that and build it up, you have all your landscape ready. This was used extensively for laminated object modeling or adhesive rapid prototyping, and the same cardboard or this thing thickness can be built and you can build beautiful architectural models. Next time you watch any movie, either the hero or heroine will probably working in an architectural firm, and one of the most attractive visual cues that is given to you is the architect's model. They will show the architect's model and saying this is the project and so on, and the bad guys try to what you call smash it, or our finicky protagonist decides to start fresh by destroying the old model. You cannot do that easily in this old type of thing, but even all of those things now have been made in sections such that the landscape portion of it is probably made separately and all the buildings and all are made separately. You can place them as you like, you can space them, and in case there is a what you call a place for a children's play area, or in case you have a what you call a swimming pool or all of those things, all of those things are easily available wherever you want, and that is where scale models like this have become popular. So, depending on your scale, usually at the bottom they write about what is the scale. So, 1:16 up to even 1:32, and some of you who have played a little with trains and you have seen the train modeling people, they are nuts typically. So, if you take one of those 9 mm models, the track spacing is 9 mm and everything is available to scale. You can have the what you call all of Swiss Alps, all of French Alps, all of Italy, everything, all the tunnels, everything, they are all available, and you can build huge systems with it and you can probably buy it online. So, I am sure when you see it you will be impressed. So, just out of curiosity, go to YouTube, look for the what you call this all this modeling, train modeling thing, and check and look for all the accessories for sale. Now, this laminated object modeling with paper, plastic sheet and all this has been extended very well. Let us say you want to show what do you call, a piece of a box like structure which has a display. Display can be easily printed and stuck onto that. So, you have a project which is, it works very well. I have a beautiful display, you understood, no? All these things including this, I make a box, I just stick it on top of it, including this and including this to make it look good. I can even have a battery, I mean a cell or a what you call battery inside, in fact having these LEDs and all, and then including these buttons, I press something, LED comes on, I can have a display which is stuck there and all that. So, making this laminated modeling also is very real, it is not. So, these all have been what you call taken from here, I would like to acknowledge, and mind you, even effective product design and good design program people have acknowledged Ulrich and Eppinger's book at that time. So, now I will just quit this for a while, and then, so you see here one of my students along with two other professors, I am sorry, three of them, he is a purely what you call functional, he designs all the, Professor Krishna Kumar does all the electronics, then Professor Gurumurthy and Ghoshal are the people who do the all the CAD modeling, and I am a person who is involved in the physical or other thing, saying he has gone to a large extent of that pointer what I was talking about, saying what all can be done, I will just sort of start it and then go back again. First thing is you need a Gantt chart to see where you start, and then components, like you have so many of these components, after gather everything, a little bit of technical study saying which is useful for us, and this is where now slowly we are coming into how do you pack all these things. Okay, this is available off the shelf. I mean, I have nothing against I mean our what do you call hardworking neighbors, but everything comes from PRC or now made in China, nothing against it, most of the people work there. You see here, if you observe something, everything is here. So, he has used that and then built up all the what do you call necessary optics here, a board here and then something, and then you see here tremendous amount of work in making all the stuff, and safety, timer module, concepts, and one of this, and finally electronics. You see here, this is ideally a 3D printed model. You see everything has been nicely, we have a product. I will continue with this now very fully. You see here, okay, I will stop here, I will continue in the next session from where I have stopped. This whole thing, I will start from the beginning again, I will continue and show you the presentation, saying this should be the starting point of any 3D printing. Hello, I can continue from a little earlier where I had left off. So, if you look at my this presentation here, it was made by one of our students, and the topic is saying how do we make a pointer which has a laser inside, which is a little more powerful than the conventional things. So, please look at this almost toy thing which has been taken from, I am not sure, some toy. Thing is, this also has all the necessary things what we think will make a laser. It has a laser diode, and then at the back we have all these what you call batteries inside. I mean a battery consisting of some 3 cells, and then there is a button, and this is, if you press the button it will start working. It is about as simple as that. Okay. So, this is in fact the starting point where the design student wanted to proceed with it. Now, you may want to know why is it that we are talking about prototypes all the time when our own interest is to talking about 3D printing. The issue being, if I now, so have a look at my monitor, invariably 3D printed parts like this are made for injection molding. Okay, and then when you make it for injection molding, certain what you call simple guidelines are passed. My suggestion is go to this 3D systems, their website, and then you can see a lot of things suited for injection molding, and then what you call about wall thickness and draft. So, enough amount of data is available. This one is a 3D printed part, except difference being, while just like we have the issue in using these plastic parts, the detailing is very critical here. One of them is, in case you want to have a metallic insert, you see here lot of trouble has been taken, bosses have been made, and the metallic insert has been inserted here. So, same thing, if you see my picture here, see here, this one looks a little like that. So, we will notice that details regarding how you assemble things together, they continue to be very similar to the injection molded part designs. And then I will just try to close this window so that we can get back to it later. There are engineering guidelines for designing plastic parts for injection molding. So, you see here, this one is a small cavity which is part of the injection molding thing. So, just let me see if it works. See here, this is a mold. If you see here, these are all those parts which in the morning I tried to show you also. Detailing is about the same for both of them. This is how actually what you call a small gasketing system is working, and then this is the usual the used thing about how to load the machine, how the parts come out. You see here, the ones including all the spruces and all the gates, part is falling down at high manufacturing, high volume manufacturing. The issue being that this one is a simple small scale press, and then a few items like this can easily be manufactured here. So, you can my suggestion you can go over the internet. That one is a what you call handle for a screwdriver. So, you can go around and check all these things. I am sure there is enough information or enough material is there saying how to make all those parts, how to make things. Please check it up. I will exit this, and we come to actually issues in detailing. Most important is, this is where the difference between an injection molded part and 3D printed part comes. In the case of these injection molded parts, we would have noticed that there is a rule applied everywhere saying the corners have to be made with a radius. Why is it? Because there is a nominal wall thickness, somewhere the material is injected, and slowly it is supposed to flow along these lines, and when it flows along the lines, several things happen. One of them is there is a tendency for it to be turned a little cold, but then those items are kept very much under control, and when you want to release it out of the mold, you end up with having to provide a draft. Draft means a small taper such that it falls out easily, and then a lot of you see all this nominal the names that are written here saying this is a rib, so that something can be held strong. Then you have a boss. A boss is what holds a circular piece inside, so that a screw or something can be kept there. And then you see this is a gusset, a triangular gusset, which makes sure that these things are maintained stiff, it is maintained. This is strengthening gusset. This is for some other, it's similar application, slightly better. And this picture has lot of detailing and data built into it. So, one of them you see here is everywhere they have given small things saying how far should a hole be away from the edge, and then what should be the spacing between the two holes, because material has to flow around the hole and go to the other one. Similarly, what should be the wall thickness, and see here, if you see here now, what should be the radius that has to be given. While it is convenient here, too sharp a radius leads to problems, too smooth a radius leads to another type of problem, because in principle the wall thickness has to be maintained constant all over the place. So, if the wall thickness varies, something called shrinkage will occur, and on the other side, on the opposite side, you will see the shrink marks on the opposite side. So, details which are very much part of this, you have seen that all these details which are shown here as part of these things, seen that, no? All of these things are there, everything, everywhere. What should be the nominal wall thickness? If nominal wall thickness is so much, what should be the radius? Okay, something regarding the radius is given here. Similarly, what should be the location of the hole size? And if you go to the top on the other end, no, what should be the thickness of the gusset? Again, same thing happens. You see, this gusset is joining this what you call flat piece. So, on the opposite side, it may lead to a small shrinkage while it is being made. Lot of this detailing is actually part of the detailing that is required for manufacturing, but it is in the designer's interest to follow these things. I want to show this to you at a very early stage, because while in this case the radius, inside radius is always half of t, outside radius is a little equals to inside radius plus t, and then base of a bus. These are slightly different in the case of 3D printed parts. To start with, it is almost impossible to give this internal radiuses, because in this case it is smooth. You inject the material, it passes there. But in the case of our printed parts, it just prints vertically. There is something which is stacked up and something which is there. There is no way of, see, this is printed and top of it, now layers of this is printed. There is no way of building a radius here. If you build a radius, it will still come dependent on the resolution of the machine. So, like all what you call catalog claims, under favorable conditions, whatever they claim, saying you can get a resolution of so much 0.1 or 0.05 millimeters, is for test samples. In your actual sample, things will vary. So, you will get a small staggered thing with a set of steps here, which by itself is not bad, but generally it is not worth building up those things. So, what generally the people do is they build straight here, and if required attach a rib here from outside, or build a rib directly inside, or leave it like that. And in general, the material is not as strong as the injection molded material, because in the case of injection molded material, lot of advantage you have on formulating of the basic plastic. So, all of us know that Lego bricks, the basic what you call brick with 8 dots, 2 by 4 things. The material has been developed specially. I do not know who is the supplier, whether it is BASF or Roman Haas or whoever supplies it, very carefully for that. It is much stronger than anything we know. Now, the original patent is over, so we have so many lookalike or clones that are available. Next time you take a clone and then you see, you will suddenly notice that the original is always better, because somebody has worked on it and made a very important thing. Same thing happens in the case of our plastic lunch boxes. All of you must have heard of Tupperware. So, Tupperware usually has a base and then there is a lid on top of it. The base is somewhat known, that lid, that particular way it bends and how the lip is created to make it water and airtight has been worked out in detail. Unfortunately, that same rule cannot be applied in case we want to make a rapid prototyping part. So, you just need to be familiar with all these data that is there, saying how do you make a rib. So, here they have given a rib has to be, you have seen this half degree draft is given here, but in our case you will not have a half degree draft. So, in case you are planning something should come inside and all that, obviously the fit will not be the same. If it is a tapered part, fits very easily, but if it is a non-tapered part, it does not fit. So, you have here lot of this data. Rib should have a draft angle of half a degree, easier ejection from the mold. So, these have been, we have this unfilled polycarbonate and what you call polymethyacrylate, then we have ABS, and how these materials behave determines a little bit of the design. And you see here also they have given what is the shrinkage. So, depending on the materials, up to 0.01 mm or that much of percentage shrinkage is there. And if you go to semi-crystalline materials, like polypropylene, polyethylene and this acetal copolymer, the things are little higher. This is almost up to the order of 2.5%. So, before we actually commit ourselves to any of these materials and all, it makes sense for us to read this available open source literature and try to make our own first prototype. Now, once the prototype is there, it is very easy for us to pass it on to a manufacturer who will now take it from there and make your parts. You have seen this during the injection and cooling stages. Several factors may affect the quality of the final product, repeatability of the manufacturing process. It is always not possible to follow all recommendations, outline and so on and so on. So, one of the typical thing is, imagine if some material is being injected here, it will flow from both directions, or I will take this corner. I am just randomly I am taking this corner. Imagine material is being injected in this corner and material has a tendency to flow here, material has a tendency to flow here, and it will come and join in this place and may end up with what is called a cold shut. So, by the time they come here, if you make it too warm or too hot, there are some problems. If you make it cold, you may end up with two surfaces joining together with a joining line which is visible, which is a little possibility of a problem. So, if you go to the internet, tremendous amount of, you have seen this, data is available here. Boss dimensions and part ratios is helpful in optimizing structures. So, in the case of a injection molding, we need to make sure that a space is left here, which is an advantage. But the same thing in the case of our building up using a rapid prototyping or 3D printing thing, we generally for various other reasons, there is no risk in our filling this whole area. All you need to do is make a circle and then fill it here fully, because layup will be easier and part will become a little more stronger. They do not do it here because, as I told you, there is this problem of increasing nominal wall thickness. If you make this problem of increasing nominal wall thickness, the whole thing will become a messy thing, especially if first of all it does not inject well and during cooling it gets badly affected. These are the small differences which you need to work out when you want to work with a 3D printing machine. Okay, now you see here threads, you have seen that, no? So, I am not very sure, feathered edge probably means something which is cut into very, very fine things, by which in manufacturing usually by turning or by any other what you call machine shop, making this rounded things is very, very tough, either internally or externally. It closely follows whatever die or the what you call tap which is used for making the operation. And here, since we have a choice, if you are to leave it straight without these rounded things and what you call it, those crests and all that, sharp edges can be stress concentrators in plastic part. Thread design should consider this. And one more important thing is, whatever is said, plastic in any form is weaker than the corresponding metal in small sections. There are special plastics with all the exemption, they are little weaker in that, and especially the common low cost plastics which we are talking about are best. So, now if I come back to this, you see here initial stages we did not know what to do. So, we overdid it, we put huge hexagonal pieces here and we tried to build a step, and then after that we tried to put the what you call this insert here, and it is really too much. It has occupied too much space and wasted so much material, and finally after the printing is over, when you try to release the part, we end up with a absolute nuisance of a part.